Here we go. We're going to look at the formula taken from our formula sheet. So you don't have to remember this formula. That's an important one. Okay, we'll look at the formula on our formula sheet and we'll use it to work out the factors of our equation. Now, this is a really common question in it, and it's really just manipulating the formula that we're given. All right, so it's a good one to get marks on, but make sure we're using it correctly. Okay, so just jump into it. Okay, I've shared my screen. Okay, so many tabs open. Get used to this again. Oops. Out of my way. Super. Okay, everyone see my screen okay? You can see me. See what I look like. Yeah, we'll go with that. Go with that. Okay, so what am I talking about? The factorization, the formula that we use. Okay. Talking about this here. Wow. Okay, this formula in front of you. Okay, so the roots of our quadratic. Okay, where we've got number in front of the A, number in front of the B, and we've got a value in at C. Okay. Sorry, guys. We've got a value in at C. We're going to take these values and put them in to the specific places. We're just going to substitute the values in where you see the letters. So this is a good one because they don't change the letters. Okay, so unlike when we were looking at completing the square on Tuesday night, they sometimes throw different letters in there just to throw you off. Okay, when they're asking you to work out the roots, okay, they don't. The A will stay as an A in the equation, the B will stay as a B, and the C will stay as the C. Okay, that's helpful. What are we trying to find out? Towards the bottom of your page, you've got the parabolas drawn out. Okay, we're familiar with these. What the roots are. Where's my pointer? Where's my pointer? What the roots are where it crosses that x-axis. Okay, so I'm looking at that third graph and where that crosses that x-axis. Okay, so where that curve, when we draw it out, where that crosses that x-axis. So when we factorize, like we did a couple of months ago, what we were trying to find out was the position where that curve cuts through that x-axis. Now this formula allows us to do the exact same thing. Okay, allows us to find the coordinates, the x coordinate specifically, of where that crosses that axis. Okay, now first thing we're going to look at this evening is how to determine whether the parabola itself actually has any roots. Okay, so when I say roots, where it crosses the x-axis is a root. Okay, so I'll refer to it as a factor or a root. Okay, so we're going to look at how we know if that parabola, the quadratic that we're working with, actually crosses that x-axis. Okay, so this is a question in itself, and it isolates part of the formula. It isolates b squared minus 4ac. Okay, so I've circled that in purple. So it isolates that b squared minus 4ac. So we're going to use this. We're going to use the b squared minus 4ac to find out whether the parabola cuts through the x-axis twice, which is the most common. Okay, whether it just touches it once, okay, or it doesn't cut through the x-axis at all. Okay, so furthest left doesn't cut through the x-axis. The middle one touches that x-axis once, okay, and the one on the right there, we're cutting through that x-axis twice. So you might get an equation, you might not see the parabola, okay, you definitely won't see the parabola if you're asked to prove it, okay, but that's what we're looking to find out. What we're doing is called finding the discriminant. Okay, so the point at which the graph cuts the x-axis are called the roots. The discriminant b squared minus 4ac. Okay, so remember that's in your formula sheet as part of our quadratic equation. Okay, discriminant b squared minus 4ac is used to find the nature. It's very important that when we find this, we refer to it in the correct manner. Okay, so b squared minus 4ac, once we substitute in all our numbers, if we get a value greater than 0, we need to state in the question that the roots are real and distinct. Okay, now what the hell does that mean? That means there are two roots, okay, and they're individual. There's two roots, and that one in the far right, and they're both separate to each other. Okay, so it's cutting the x-axis at two places. So that b squared minus 4ac, that we're seeing here, okay, is greater than 0. The roots are real and distinct. Okay, so when we substitute our numbers in, if we're getting an answer greater than 0, then it should be quite obvious. Okay, the roots exist. Okay, they cut through the x-axis twice. If we get an answer to equal 0, the roots are real and equal. Okay, so there is a root, but if it equals 0, there's only one root. So that's what we're talking in the middle there. Only touches the x-axis in one place. So the root of that equation is also its turning point. Okay, so the root of that equation is also its turning point. And then we've got that last one, b squared minus 4ac is less than 0, means there's no roots at all. Okay, it doesn't touch or cross the x-axis. Okay, so we're looking at that sort of setup. Okay, so let's have a wee look at a few examples. So we've got quadratics in our normal form. Okay, very thin pen. Oh, very thick pen. No judging there, no? Wow. No in between with this pen, is there? There we go. So ax squared plus bx plus c equals 0. Okay. Now, to find the discriminant, we're using b squared minus 4ac. And the letters are taken exactly from that quadratic equation. Okay, so the b, we're substituting in to our formula. It's just any number that's front of that x. Now remember the sign's important. So that's a positive 3 in this case. So I'm getting 3 squared. Minus 4, always the 4, multiplied by a. There's nothing in that a position. Okay, so remember in algebra, there's nothing there. We refer to it as 1. Okay, so there is 1x squared term there. Okay, and then in the c position, we've got that number 4. Okay, so 9 minus 4 times 1 times 4, which is 16, is going to give us an answer where b squared minus 4ac is less than 0. Okay, so that's going to give us an answer of minus 7. Okay. What does b squared minus 4ac less than 0 mean? Okay, it means there's no real roots. Okay, so b squared minus 4ac, because it's less than 0, means there's no real roots. I should be able to put this into Desmos, and we should see that that doesn't cross the x-axis. Okay, so let's see if this works. Get out of my way. Okay, so I had x squared plus 3x plus 6 plus 4. Okay, now if I zoom out a wee bit, you can see that parabola. Okay, you can see that parabola. You can see where that x-axis is. Okay, it's that horizontal line down the bottom. Okay, so that's where our y is equal to 0. You can see the parabola doesn't touch or go through that x-axis. Okay, so we got the answer b squared minus 4ac is less than 0. Therefore, there are no real roots. Okay. Can't see Desmos. 2 seconds. See Desmos there. Yeah, okay. So you can see that parabola. So I've put in the formula that we're given, x squared plus 3x plus 4. You can see that parabola does not cut through that x-axis. Okay, the turning point's above it there. Okay, so when we're getting the answer, oh, cancel that. That'll leave me. We're getting the answer b squared minus 4ac less than 0. We need to write that b squared minus 4ac is no real roots. And we need to state that in the question. Okay, so when we're getting asked the question in the assessment, we need to state that there's no real roots. Okay, it was above that x-axis line. Have a wee look at the second one. Okay, so we've got 4x squared. Again, ax squared plus bx plus c equal to 0. So it's in a normal quadratic setup. We're looking to work out the discriminant. The discriminant is b squared minus 4ac. That's given in your formula sheet, remember? Okay, b in this case is 7 minus 4 times 3. 49 minus 16 times 3 is 3248, which is equal to not 0. It's equal to 1, obviously. Therefore, I can say that b squared minus 4ac is greater than 0. Therefore, there are 2 real and distinct roots. Okay, so the fact that that's b squared minus 4ac greater than 0 means there's two real and distinct roots. Okay, so we need to state that. Remember, just saying there's two roots is not accepted as an answer. You would lose a mark for that. So you need to say the roots are real and distinct when it's greater than 0. Have a wee look at that equation, 4x squared plus 7x. Plus 3. Oof, tight. I thought I got it wrong there. But you can see that that cuts that x-axis, okay, in two locations. Okay, cuts there at -1, 0. It cuts there at -0.75 and 0. Okay, so it's got two real and distinct roots. Any questions so far? Cool. Happy days. All right. Let's have a look at a couple more.
Daniel, can I ask a quick question?
Go for it.
Sorry, I'm just a bit confused. I don't know if I missed a bit. See where you've done 7 squared minus 4 times 4 times 3. See the minus 4 times 4. Where are the numbers coming from?
Okay. Okay, so that b squared minus 4a and c, that goes back to our equation. Okay, so that's a, b, and c there. Okay, so when we started looking at quadratics, we put it in this format where ax squared, so a is the number in front of the x squared term, b is the number in front of the x term, and c is the number that stands alone, the whole number at the end. Okay, and we equate that to 0. So the b squared minus 4ac, those letters refer directly back to that format. Okay, so the b squared is a 7. 4 is always
I get it now. I get it.
a substituted in from there, and the 3 comes from the c position.
Yeah. No, it was just me being silly. No, thank you.
No trouble at all. See, the thing is, if you've got a question, ask it, because I guarantee you're not the only one with the question. Okay, let's have a wee look at a couple more. Asking for the discriminant. This one, now you don't have to write ax squared plus bx plus c equals 0. I find doesn't hurt. Okay, b squared minus 4ac is a part of the formula that we use. B squared is minus 3 squared minus 4 times 3 times minus 6. Okay, so a lot going on here. So minus 3 times minus 3 is going to be positive 9. Minus 4 multiplied by minus 6 is 24. Multiplied by 3 is going to give us positive 72. Okay, so that gives us 81, which is obviously greater than 0. Therefore, there are two real and distinct roots. Okay. Ax squared minus plus bx plus c equals 0. B squared minus 4ac to find the discriminant. B is minus 1 squared minus 4 times 4 times 2. Okay, so minus 1 squared is 1 minus 1632, which is equal to minus 31. Therefore, b squared minus 4ac less than 0 means there's no real roots. Checking order, no real roots. Okay, so that's sometimes the question itself. All right, sometimes the question in the exam will simply just be that. Okay, so that on your screen there is a past paper question from 2018. Okay, that's the answer we're looking for. Okay, but let's have a wee look at what it's asking us to do. So it gives us determine the nature of the roots of the function. So it's asking us the nature, so we're working out the discriminant. Okay, the fact that that says fx just means they've written it in functional notation. Okay, now we'll go back to that and cover that later on. But essentially, we're doing the exact same process to that equation, that quadratic. Okay, so if I rewrite that, 2x squared plus 4x plus 5, just as a wee reminder, plus bx plus c, just equate that to 0. Discriminant is b squared minus 4ac. B is 4 minus 4 times 2 times 5. Okay, so 16 minus 40 is equal to 24 minus 24. Therefore, b squared minus 4ac is less than 0. I don't know why I struggled with that one. Okay, which means there's no real roots. Okay, so no real roots, this discriminant is minus 24. Okay, so they'll ask us for the nature of the roots or something about the discriminant. Okay. Let's take a wee note of that past paper question. So past paper 2018, paper 1, question 8. Okay, just take a wee note when we're going through that. Obviously, this is recorded. I hope. Okay. Determine the nature of the roots of the function. Again, go through our same process. 7x squared plus 5x minus 1. Just equate that to 0. Ax squared plus bx plus c. B squared minus 4ac. Okay, remember that part is given. You don't need to remember that part. That part there, that first line I did, is just a normal format for our quadratics. Okay. B squared minus 4ac is 5 squared. Minus 4 times 7 times negative 1. Okay, so 25. Now, just watch out for these signs, because there's a negative there and a negative there. Negative 4 times negative 1 is positive. Okay, it turns into a positive. So 4 times 7 is 28, so it's going to be plus 28, which is going to give us 53. Okay, therefore, b squared minus 4ac is greater than 0. And there's 2 real and distinct roots. Okay, so it's quite a nice question. Just need to remember the wording and make sure you put the word real and distinct. Okay. There's one other way they can ask this question. And it's a wee bit awkward. Okay. But sometimes they'll ask to find the value, okay, or find the range. And they'll give you in a format with a letter in it. Okay, in this case, K. What you're wanting to do here, when you see that word roots, you know you're going to put it in the format b squared minus 4ac. When we go through the process of solving that, instead of the letter A, we're going to substitute in K value. Okay, so let's have a wee look at that. So B is 5 squared minus 4 times K times C, which is 10. Okay. 25 minus 40K, essentially. Then we're going to have to change the sides of these numbers. Okay, so I want to leave K on its own. Okay. I want to leave K on its own. Sorry, I put the wrong symbol in there. How do I know what I'm equating this to? Okay, is this part here has equal roots. Okay, that's why I knew I have to put it equal to 0. Okay, so equal roots. If that said I had 2 real and distinct roots, okay, then I would know that it would have to be greater than 0. So the symbol in here. And if I had no roots, then it's going to be less than 0. Symbol in here. Okay. Find the value of K, given that it has equal roots. So I want to isolate what I've circled in blue there. So I'm going to move over everything else. So I've got minus 40K is equal to 25. K is equal to 25. I'm going to take that whole thing and move it over. Okay, so I have 25 divided by negative 40. Okay. I want to simplify that down. 5 goes into the top line 5 times. 5 goes into the bottom line 8 times. Still a negative. Okay, that would be my answer. Negative 5 over 8. So there's a couple of things happened there. Okay, so it's a different way of them asking us the question. It's asking us to find the value of K, given that the quadratic has an unknown in it. Okay, so we have to find the value of that unknown when it's got equal roots. So that equal roots gives us the sign equals to 0. If it's an equal root, it only touches once that x-axis. Okay. Let's have another example of that. So again, find the range of values of P. So we're given a quadratic and we've got an unknown value in it. Okay, so we're given a quadratic and it's got an unknown value in it. And we're finding the values that to allow the equation to have no real roots. Okay. So when do we write that? Px squared minus 2x plus 3. Take that by x a wee bit. We're going to write it in the form b squared minus 4ac. The fact that it's got no real roots means that b squared minus 4ac has to be less than 0. Now we're substituting in the numbers. So b is negative 2 squared minus 4 times p times c, which is the number 3, and we have to be less than 0. So negative 2 squared is 4 minus 4, 12p. Zero. Move over that number 4 to leave us with negative 12p. Oh, equal to negative 4. And here's where we need to remember our rules of inequalities. Okay, so remember when we first seen these signs, greater than or less than, okay, and we rearranged equations, there was a rule that when we take across a negative number to the other side, okay, it flips that arrow around. Okay, so when we take that negative number to the other side, it stays a negative, but it flips the arrow around. That becomes P is now greater than negative 4 over negative 12. Run out a wee bit of space. So P is greater than, it goes in it once, and it goes in it 3 times. The negatives take each other out, so 1/3. Okay. That's your answer. So there's a lot of things going on there. A lot of things going on there. Remember in our inequalities rule, okay, is mixed in with that question. But also we have to know that it has no real roots. Okay, so it doesn't touch the x-axis. So b squared minus 4ac has to be less than 0. Okay, for that to happen, p must be greater than 1/3. It says range here. That's a range because it's any value greater than 1/3. Okay, so any number that's bigger than 1/3 could go into that equation and have no real roots.
Daniel, do you still have the working of the question that we just done before that?
Aye.
Just the one. Aye, so see that one?
Yep.
You know how we're moving a positive 25 over to the other side? How come it never changed to negative there?
Oh, that's a great shout. Well done. It does. Superb. Thank you, Carla. That was Carla.
I'm getting better than you.
Oh, see, I'm looking at it and it's massive. All right, so it's a lot harder. Give me grief. Put it in a full board. All right, great shout. Yep. So, back to this equation. Okay, so remember, this is in our formula sheet. What we've just been looking at is this wee bit here, the b squared minus 4ac. That's how we determine the nature or discriminant. Okay, so depends how they refer to it. Okay, now once we determine that it's got roots, okay, so our first process in any of these questions is determining whether it has roots. Okay, so anything when this value b squared minus 4ac is greater than 0, we can use this equation, okay, for any factorization. 9 times out of 10, this will be in the calculator paper. There's a couple of different questions that could crop up in the non-calculator that ask for proofs and things like that, and you need to do that, obviously, without the aid of a calculator, okay? But the numbers in that case should be relatively simple, okay, or you won't have to do the root part. Okay, but let's have a wee look and just work our way through that. So that line, that whole line will be in your formula sheet in your exam. Why we need to use this is when we were doing factorization early in the year, okay, we were getting whole numbers out of it. When this happens, when we're using this piece, this full formula, okay, we're going to get decimals out. Okay, give your answers to correct. Sorry, give your answers correct to 1 decimal place or 2 decimal places will normally be said or will be said in these types of questions. That's your giveaway that you won't be able to do your normal CDT factorization. Now, by using that equation, we're doing the exact same thing. Okay, but if it's asking for a decimal place, when you see this, don't go through the process of looking for a common factor, looking for difference of squares, of 2 squares, or looking for the trinomial to go through that. Okay, if you see it's asking for decimal places, jump straight in to using this formula. Okay, which I won't have a copy of. So let's just write underneath this, ax squared plus bx plus c equals to 0. Okay, and then from our formula sheet, from our exam paper, x, which is our factors, okay, so where it cuts the x-axis, okay, equals minus b, remember that minus sign, plus or minus, I'll explain that in a second, the root of our discriminant all over to a. We need to substitute in the numbers from our quadratic into our equation here. Okay, so negative b is going to be our b value. We need to put a wee negative sign in front of it. So if it's positive in the question, it becomes a negative. If it's negative in the question, it becomes a positive. Okay, so just watch out for that. I'm going to leave this as plus and minus, and I'm going to do root of 9 squared minus 4 times a, which is 3, times c, which is negative 2. And it's all over 2a, which is 2 times 3. Okay, I'm going to tidy this up a wee bit. I'm going to tidy up the discriminant. So I'm just going to leave that minus 9 there, plus or minus the root. 9 squared is 81, and we're plussing because we've got a negative 4 and a negative 2 multiplied together. Okay, so negative 4 times negative 2 is plus 8, times 3 is plus 24. Okay, so we've got 81 plus 24, which is 105, all over 6. Okay. Oops. I have to give myself a wee bit more room. If you can't see that, if it becomes too small, remember I've got this in a massive bold, all right? If it becomes too small, give me a wee shout. So I've got the line equals -9 plus or minus root of 105 divided by 6. Okay, so I want to explain this plus or minus. This plus or minus is there because we're going to get two answers out of this. So at this point, we can split this equation into -9 plus root 105 over 6. And we can get another answer by doing -9 minus root 105 divided by 6. So you're only given it in one format at the start, but this plus or minus at the start breaks it into two separate equations, one using the plus and one using the minus. Okay, then it's a case, oops, sticking that in your calculator and getting out what hopefully should be these two answers. Okay, so have a go at sticking that in your calculator. -9 plus root 105 divided by 6.2. Okay, remember one decimal place. We're rounding that 0.2. Okay, the second one. We're going to minus instead of plus. We're getting -3.2. Okay, so that's our roots of the equation. Okay, if we were asked for the coordinates, where it cuts the x-axis, coordinates would be 0.20, -3.20. Okay, I'm just going to throw this into Desmos just cause. All right. Remember what it was. 3x squared. Plus 9x minus 2. Okay. If you can see that, there's my parabola. Okay. You can see it cuts the x-axis in two locations. So it's got two real and distinct roots. One of these locations should be 0.2. Okay, and one of the locations should be -3.2. Okay, so that's what that equation's given me. It's given me where it's cutting the x-axis, but because it's not a whole number, it's not easily factorized, we need to use that equation. Yeah, does that make sense, guys? Any questions there? Okay. Have a wee go at that one yourself. So this is question 4 of paper 2 from 2017. Okay, you've got ax squared plus bx plus c. Give your answers to one decimal place. So we're using, yes, if we try to factor it, we're going to go, yes, okay. If you're struggling to factorize something and you're not sure, go just use the equation and it should help you out, okay? But if it doesn't ask for one decimal place or anything significant figures or anything along those lines, there's a good chance that the factorization will just be done in the normal way, which is your common factor, difference of two squares, or your trinomial, okay, where we try and multiply to find the last number and add them together to find b. Okay, if that makes sense. Yeah. Okay. X minus b plus or minus root of b squared minus 4ac all over 2a. You can even do that part separately. Okay, I'd probably recommend that you do, and then just substitute it in. Okay, so you'd have 5 squared minus 4 times 2 times negative 4. Okay, so 25 plus 32 equals 57. Okay, we bring that back in, pull it together with everything else. Negative 5 plus or minus root of 57 all over 2 times 2. Our two equations, negative 5 plus root 57 over 4, and x equals negative 5 minus root 57 all over 4. Putting that in the calculators should spit out those answers. Point 63, so 1 decimal place. Okay. So need to for the coordinates 0.60, negative 3.1, 0. Okay, that's your two factors, it's your two roots where you're crossing that x-axis. So Dylan's asking, is there any common mistakes or things that will catch us out? Tends to be the mistakes come from not putting the negative signs in correctly. So where you've got that negative b, you sometimes forget to put the negative in or change it. So if in the equation, say that was 2x squared negative 5x negative 4, you would have to change that negative 4x or negative 5x, sorry, into positive 5. Okay, and that will sometimes throw people. Okay, other than that, common mistakes, not really. Okay, once you've done a couple, the splitting of that is pretty straightforward. Okay, but it's just that negative sign in front of that first b. Or we look at that. There's another past paper. Another past paper, guys, so I'll give you a second just to try and start setting that up. Okay, I'll give you a wee second just to start setting that up. Okay, remember, pull the b squared minus 4ac over to one side and just solve that, and then bring it back into it. Okay. Okay, use the appropriate formula, quadratic, blah, blah. X is equal to negative b plus or minus root b squared minus 4ac over 2a. Okay, just always write that out. I know you're given it in your formula sheet, but just always write it out. Okay, I'm going to take the b squared minus 4ac over to one side. Okay, b is 3 squared minus 3 times, oh, sorry, minus 4 times 3 times minus 7. 9 plus big number, so 12 times 7 is 84. Okay, so we've got 9 plus 84, which is equal to 93. Okay, and substitute that in instead of trying to write that out. So negative b, oh, sorry, negative 3 plus or minus root of 93 all over 2 times 3. Then we separate them. X equals negative 3 plus root 93 over 4. No, 6. Why have I written 2 then? Okay, over 6. And x is equal to negative 3 minus root 93 all over 6. Okay, putting that in our calculator should give us out the answers up there. Is anyone not seeing where these letters are coming from? Anything about it? Yeah, so if in your trinomial the b term was negative, in your formula it would become positive. Okay, so someone was just asking about clarifying, okay, that b term plus or minus. (1.1), good. X minus 2.1. Okay, so ask for the coordinate. I'll ask you to sketch it. That's your roots. Sorry. Not too bad. Okay, just remember to refer back to that question. Okay, so that was practice paper 2, question 8B. Nice one. Okay. Now you've seen all our questions up until now. Okay, they've already been in the form ax squared plus bx plus c equals to 0. Okay, but that's not always going to be the case. There's some occasions like this, okay, where it's not set up quite like we'd expect. Okay, but this is asking us to recognize, solve the equation the 1 decimal point. This is asking us to recognize that that is a quadratic. Okay, we could set that up in our normal format. Okay, so we could set that up by bringing this 9 back over and just equating it all to 0. So if I leave nothing on that right hand side, then I'll just put the number nothing. Okay, so x squared plus 2x, and I'm going to bring that 9 over, so it's going to become -9, and it's going to be 0, and then it's in a format that we can then use our equation x equals -b plus or minus b squared minus 4ac all over to 8. Okay, so if you work through and just solve that and get those answers for x out, okay, the only way they've thrown in to trick you there is just by putting that 9 on the right hand side of the equation and not having it all to 0. Okay, so it's still a trinomial. By asking us to solve, they're looking for the roots, they're looking for us to find factors. Okay, the point at which they cross the x-axis. The fact it says decimal point means we're using that formula. Okay, so take a second and just work through that. So this one in our worksheet telling us to be careful. Okay, so it's obviously telling us to be careful. The fact that we've got these negatives. Okay. Now we could approach this in 2 ways. What I think I'm going to do is I'm going to change the side of all these terms and create a positive x squared term for us to work with. I think that would be the best way. Okay, so I'm going to take this whole x squared term and move it over. Okay, so it'll be 4 minus 4x equals positive x squared. Likewise, I take this term, move it across. Positive 4x, and then we'll just move our last term across to give us a 0 on the left hand side. Now, that's in the format that we're more used to. Okay, we can pick out our ax squared plus bx plus c off of that. Okay, so let's have a wee look, make sure this works. So negative b would be -4 plus or minus root of 4 squared minus 4 times 1 times -4 over, oops, 2 times 1. So my 2 equations, a wee bit smaller. 2 equations would be x equals -4 plus, and that would be 16 plus 16, so it would be root 32 over 2, and x equals -4 minus root 32 over 2. And -4 plus root 32. 0.82. How many decimal points? 1.8. X. Hopefully, if I look back at the answers. Negative 4.8 and 0.8. All right. Four minus. All right. Then I'm not sure what I did there, what I worked out there. Happy. Good sign. There was another be careful one, so let's have a wee look. 2x squared equals 3x plus 3. 2x squared equals 3x plus 3. In fact, I'll snip that one. Okay, this is just a wee bit of rearranging again. Okay, so we've got 2x squared on one side. I want to move over my 3x and I want to move over my plus 3. Okay, now they're both positive on the right hand side, so they'll both become negative on the right, on the left, and we'll end up equal that to 0. Okay, now I've got my ax squared plus b x plus c. Okay, and I can put that into my equation, negative b plus or minus root of b squared minus 4ac over 2a. Okay, I'll take my b squared minus 4ac over to one side just to give myself more room. So it'll be negative 3 squared minus 4 multiplied by 2 multiplied by negative 3. So that would be 9. Minus 4 minus 3 would be 12 times 2, 24. So it'd be positive 24. Leave the 33. So my equation would be negative b, which is give me a positive, plus or minus root of 33 over 2 times 2. Positive 3 plus or minus root 33. Oh. Got it. Split that up. So x equals positive 3 plus root 33 over 4. Terribly drawn 4. Okay, we'll split the other one. The x equals 3 minus root 33 over 4. Putting that in my calculator. The plus root 33 over 4. The one decimal place would give me 2.2. And negative 0.7. Okay, so that goes back to my be careful with this sign. Okay, so remember this is negative b, so it's a negative here, okay, it was a negative at this point, then it becomes a positive in our formula. Okay, the start of our formula. Remember, you're given that formula. Okay, so you don't need to remember it. Is there any other one jumping out? Right, let's have a wee check of that answer. Negative 0.7. Negative 0.7 and 2.2. Is there any other of those answers jumping out? You okay? Okay, so tricky part of that is rearranging, and maybe something else that will trip you up is just that positive or negative for the B value. Okay, I'm going to put this one on the screen, this application question. Snip that. Snip, snip. Okay, this time we're getting given. This time we're getting given the parabola. All right, so we're seeing root A and B. Okay, so we're getting given a wee picture of the parabola. Okay, that's a good helper. Okay, we're getting given a wee picture that allows us to see or give us an idea of where A is going to be and where B is going to be on that x-axis. Now, with that line and that line, I've got a y-axis there that A is to the left of. The A being the left of that means A is going to be negative, B is going to be positive. Okay, that's a wee step for a hint. We just work through that in the normal way. We've got the quadratic, it's already in the form that we want it. We get given x equals minus b plus or minus root b squared minus 4ac over 2a. I'll just take this to one side, give myself a bit of room. B squared minus 4ac is equal to minus 4 squared minus 4 times 2 times negative 3. So that's 16. The two negatives multiplied together make a positive. Plus 24, up to 40. Okay, so root 40 is going in there. Negative b in my function that I'm given, b is a negative. So in my formula, remember, that will become positive, plus or minus root 40 over 2 times 2. Okay, we have one equation 4 plus root 40 over 4. 4 is going on. We'll have another equation, x equals 4 minus root 40 over 4. Putting that in my calculator. What am I saying? Three significant figures, 2.58 and negative 0.5. Yeah, so we double check. Point 581 and 2.58. Oh yeah, 3 sig fig. All right, so it's given the coordinates. Okay, so the coordinates 2.580. Okay, so y is equal to 0. Okay, and negative 0.581 and 0. Okay, that tells me this one is A. This one is D. Okay. So read the questions. I was giving you coordinates earlier on, and I forgot to do it there. Okay. Let's have a wee look. What else did I have up? I missed out. Okay, I had this one. So this looks horrible. All right, it looks a bit bizarre. But let's look at the clues and what it's asking us to do. The roots of the equation, we're given a quadratic, can be expressed in the form blah, 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 blah. Okay, I'm looking at the word roots and I'm looking at the fact that we've got a quadratic. My head immediately is going to the fact that you're solving that using a formula. Okay, the fact it's asking for roots, my head is immediately going to minus b plus or minus root b squared minus 4ac. Sorry, I did that tiny. Over 2a. Okay, so roots of a quadratic, my head's going there. Okay, now look what it's asking you to do. It's asking you to find the values of d and e. It's putting it in a weird way that d plus or minus d root e. Okay, again, this is giving us another clue. This bit plus or minus, we don't use that anywhere else in that 5 maths. Okay, that's only used in this formula. Okay, so again, that's giving me another clue that I'm using this formula to solve this. Okay, now this came up in paper 1. Paper 1 is a non-calculator paper. Remember. So this is a non-calculator paper. That's why they're asking in such a way, because to solve that root, you're probably going to have to use a calculator. All right, you're not going to be able to solve that in your head. So there's a few things jumping out. The fact it's in a non-calculator. Okay, it's asking for roots and it's asking for roots of a quadratic. It's asking it for a form that's showing a plus or minus. Okay, all of them are using the formula. Okay, that's clues pointing at this formula. Let's throw some numbers in the formula and see where it takes us. Negative b would be plus 6, plus or minus root. Tell you what, we'll do the b squared over a wee bit. The root in, do b squared minus 4ac. B squared is negative 6 squared minus 4 multiplied by 1 multiplied by 81. 36 negative 4 times 81. Okay, so you can do that in a couple of ways. You could do long multiplication. Okay, where you've got 4 times 8 is 16, 32. Okay, 324. Anything negative? The A1's negative. Okay, so I'm positive 324. Okay, some big numbers happening here. Equals 330, 360. Root 360 all over 2. D and 6 into that. 2. All right, okay. X equals 6 plus or minus. What it's asking us to do is simplify this. Okay, so E is 10. Yeah, okay. Simplify that root 360. So it's going back to stuff we did a couple of months ago when we can break up surds. Okay, the stuff we did in surds. Now, what that 360 is we can break that down into root 36 multiplied by 10. You put that all over 2. Okay, we can simplify that even further by saying 6 plus or minus root 36 root 10 all over 2. Okay, I need some more space. That's that out. Okay, now that root 36 simplifies down. Okay, root 36 is 6 times 6. Okay, so that root 36 can become a whole number. X equal 6 plus or minus 6 root 10 all over 2. Now I want to get rid of that 2 in the bottom. Okay, to do that, I'm going to treat that top line, okay, equation itself, I'm going to take out a common factor. Okay, that common factor probably 36. Okay. 6. 10. To allow me to do that, and get rid of 2. Okay. And then breaking that bracket back up. Give me that. And it's in the same format. What we got asked in the question. That is a mean question. That's an unknown calculator, remember? Okay, so the final answer on that would be what is letter D? D equal to 3 and E is equal to 10. Okay, and that's your final answer there. So there's a lot going on, and for the second time tonight, it's pulled in stuff that we did in another section. Okay, so seemingly they like to do that in these types of questions. So that's pulled in our understanding of how we can rearrange subs. Okay, so at this point here, we had to break that sub up. Okay, the non-calculator means you have to do that 81 times 4, okay, on your own, no calculator. So learn how to do that. Okay, and then back to subs.
And you'll see where it's right at the start, the second line of working you've done. How come it's positive 6 instead of minus 6?
So that is going back to Dylan's question way back, all right? So that negative b takes into account that number in front of the x term, all right? So this number in front of the x is a negative. So if I'm taking that negative and I'm making it a negative again, essentially the negatives are ruling each other out and it becomes a positive.
Right, okay.
If I'm getting a negative here, in that b term, it becomes a positive when it gets put into the formula.
Right, thanks.
All right, so if we look back at another one, if we look back at that one, you can see that b term is a positive there, and it becomes a negative when it gets put into the formula. Okay, so whatever the sign is for b, because of this, change it, flip it. Okay, so that formula minus b plus or minus b squared minus b squared minus 4ac over 2a. Remember, you're given that. Okay, so you're given the fact that that's negative b. That's why I always write it out. Okay, so don't take a shortcut and just go straight to that line. Okay, write out that and use that, make that serve as a reminder that you need to change that sign. Okay, that's as horrible as that question can be. That's taking into account a few different things. Does it come up a lot in the non-calculator? As much as anything else. Okay. Often the non-calculator, if it does come up, it will ask you to leave it in a format, okay, with the root still intact. Okay. See if I can find any more in it. It's a time, 8 o'clock. Sorry. Okay, guys, if you're still with me, just quickly go over the sort of completing the square stuff. So we did quite a bit of this on Tuesday night. So I'll just cover it very quickly. Okay, so you've just got a bit of an understanding. So completing the squares is important. Okay, completing the square means we're putting the quadratic into the format of x plus a squared plus b. Okay, that sort of format. Now, what throws a lot of people in this is the lettering that they use to represent that format doesn't follow the convention that we use for quadratics. All right, so for quadratics, when we say ax squared plus bx plus c, okay, those two letters don't come directly from there. Okay, but frustratingly, they don't come directly from there. Instead, what you need to do to reformat this is the following steps. Okay. X plus the b term over 2 squared minus, and always minus, the b term over 2 squared plus the c term. Okay, so when I've done those letterings now, that b term, and that c term now refers back to our ax squared plus bx plus c. Okay, so my b goes in here, my b goes in here, and my c goes in here. Okay, when they ask you to reformat the question, okay, and we'll pull up a couple of past papers to look at it, they'll ask you in a bizarre way, all right, but we just need to recognize that and follow the process anyway. Okay, so just tidy that up. Let's see more examples we did on Tuesday. Seconds, guys. Oops, maybe not. Sorry. Okay, so in that first one then, to complete the square, got x plus 8 over 2 squared minus, always minus, 8 over 2 squared, and then we've got the c term. So my final answer would be x plus 4 squared minus 19 for that. It's a really bizarre process. All right, that's the best way I can explain it. It's a really bizarre process. Just check the answer. Okay. What it's for is to allow us to find the turning point of the quadratic. Okay, it allows us to find the turning point. So if I put that into Desmos, which is somewhere. Okay, so if I put that x squared plus ax minus 3 into Desmos, I'll see the turning point down there. Okay, so where we get a minimum point on that quadratic, that shape in our graph, we're getting a turning point of -4, -19. Okay, so that coordinate we can lift from our completion of the square. Okay, so we've completed the square, and if we get asked for the turning point, our coordinate is going to be minus whatever we've got in here. Okay, so -4, and then whatever this last term is, -19. Okay. Again, awkwardly, you have to change the sign of that term. Okay, so +4 when we complete the square. When we do the turning point coordinate, it becomes -4. Okay, so let's do another one. So completing the square, number 2, x minus 6 over 2 minus -6 over 2 squared minus 1, x minus 3 squared minus, okay, and it's minus 3 squared, which is 9, okay. So we do that bit first, but this negative sign is always going to be in place. Okay, so we're going to get 9, negative 9, negative 1. Our final line is going to be x minus 3 squared minus 10. So our turning point will equal 3, negative 10. We've changed that sign as we bring it down into the x coordinate, and we keep that as is to bring into the y coordinate. Okay, so by completing the square, we can find the turning point. Any questions so far, guys? Okay, just to keep going then, complete the square. X, it's a minus because that's minus there, so minus 2 over 2 squared minus 2 over 2 plus 7. X minus 1. Sorry, we squared up there. Minus 1 squared 1 plus 7. X minus 1 squared plus 6. So my turning point would equal 1, 6. Okay. X plus 10 over 2 squared minus 10 over 2. That's always a minus, remember. Squared plus 13. X plus 5 squared minus 5 squared, which is 25, plus 13. X plus 5 squared minus 12. So our turning point would be negative 5, negative 12. Okay. Have a wee go at the worksheet for completing the square. Okay. And that will help you out with that.